which is from Helena Handschuh. Helena is a fellow at Rambus, specializing in cryptography and embedded security, and has been involved with RISC-V as the chairperson of the Security Standing Committee. So she's going to give us a kind of an overview of security-related topics within RISC-V. I hope that's not too bad a representation.
No, that's perfect. All right. Thank you for the introduction. Let me try to see if I can share. Does this work? Can you see my slides?
Yes, that works great.
Okay, cool. I'm trying to go full screen, so let me know if that doesn't work out, then I'll make it smaller. But okay, so just a little bit of an overview. This first talk, there's really nothing technical in it. It's just so that people get a good understanding of kind of how RISC-V works and how you can participate in security activities, how you can be part of it, how you can bring something to it, and how you can benefit from it in return. So let me move forward, see if that works too. Yes. Okay. Just going to do one more thing, which is move the little bar at the top. Otherwise, I don't see the text. Zoom. Okay, here we go. So RISC-V at a glance. So the chairman of the board are Krista Razanovich and David Patterson. You might have heard of David Patterson before. He has received the ACM Turing Award in 2017, and they both have been involved in RISC-V, in RISC for a long time, and in RISC-V more recently. The CEO of the organization is Callista Redmond. There's a CTO called Mark Himmelstein. There's also somebody in charge of visibility, that's Kim McMahon. And it's a rather big organization now. There's more than 13 premier members and like 150 strategic members, which means companies and bigger organizations, and more than 1,000 members in total. So these are all combined together, over 1,000, but you can actually join. So if you didn't know, you can join as an individual, and there's no cost to that at all. It's completely free. You can also join as a university, and that is also free, I believe, since last year or so. So there are many ways of joining, and there should be one that fits you. Okay, so what does it do? Well, it owns and standardizes the base specifications of the RISC-V instruction set architecture, which is composed of two specifications, the unprivileged one and the privileged one. It's completely free and open, meaning anybody can download it, use it for anything you want. And it also starts creating extensions now. So from the base, there are extensions built on top of it, and we will see some of them are actually relating to security. We'll see that a little bit later in talks following this one. It does standardize these additional extensions for all sorts of things, for example, for specific acceleration, for specific use cases, for specific applications. So there's one dedicated to crypto, for example, but there's also many others dedicated to all sorts of other use cases and applications you might have in mind. It goes all the way from hyperscale, high-end spectrum to all the way to the IoT tiny embedded devices. So no matter which market you're in, which segment you're in, or what you want to study or accelerate or optimize, there'll be one for you. And if there isn't one, you can join and create one. That's the cool thing about it. There is also now starting to be a software and hardware ecosystem. So for that, you can visit the riscv.org/exchange site, and there you will see everything that people have contributed so far. So contributions by members themselves, and then there's tool chains, simulators, boards, software, security solutions. People contribute to all sorts of things. And it's very interesting to see that you can use it to try out your own implementations and so on. Not everything is free from what has been contributed by the members. Sometimes you'll find people have commercial solutions posted there, but you can pick and choose and surf around and see what's available. There's documentation there, platform specification, profiles, and so on. And everything that, everything that RISC-V does is public. All the mailing lists are public, all the information is public. Mostly everything is posted on GitHub or Google Docs, Wiki, and on that special link here, lists.riscv.org. The only thing that you have to be a member for is in order to participate and to contribute and to influence what's going on. Otherwise, everything is just public and you can use it, download it, and so on. Okay, so that's RISC-V at a glance. See if I can get to the next slide. No. Yes, okay. Just a little bit of an idea of what the structure looks like. The technical organization looks like this. It's driven by a board of directors of members of the different member companies. And then there's a technical steering committee and a CTO. And then there's all these groups that are working on all sorts of different things. So you can see here, the main two areas are the unprivileged spec and the privileged spec here. And what's in green, shown in green, is already ratified. That means that it's stable, has been voted on, and it's not going to change going forward. And then there's all the technical working groups, the TGs that work on different extensions. They're all listed here. I'll say a few words about them, but not too much. You can go on the website and figure out all of the groups that exist. And then there's so-called horizontal groups. So that means these are groups that have specific interests, but that kind of span all of the specifications. So for example, the one we're interested in, of course, is security. And this one is kind of involved with all the other groups as well, because there might be, people might be writing specs, inventing new specs, and introducing security bugs. So we need to be taking a good look at all the other specs that are being written to make sure that security-wise we're happy with them. So anyway, these are horizontal groups that go that have a special interest that goes a bit everywhere. Safety is another one that some people might be interested in. That's a little bit more automotive related, but that's also a horizontal group. And then in the task groups themselves, we have two of them that are very specifically creating security extensions or documentation or guidelines or things like that. So one of them is the crypto task group, and the other one is the TE task group. They're both highlighted in blue here. And we will hear, I believe, later on in this workshop from the crypto group that has just published a specification for review. And we will also hear from the chair of the TE task group all the different other security topics that are going on beyond just crypto in terms of, how to secure a system. So there's two talks dedicated to that later on. Okay. Now, what we have already, as I mentioned before, is two specs that are stable and have been stable for a while. So these are the base specification. The first one is the user level ISA, which is the base specification, which kind of doesn't have too many privileges at all. That's the top one, where you sit at the top above all of the other ones that have more privileges. So this one has been stable since about 2019, even before that, but it's been ratified in 2019. And it gives you all of the base ISA in 32-bit, 64-bit, and 128 bits. And on top of that, it has extensions available already. So for example, extensions for atomic instructions. You see all of them listed here on the right-hand side: single precision floating point, double, quadruple floating point, decimal floating point, compressed instructions, and so on. And there's two that kind of relate to security and crypto a little bit more than the others. That will be mentioned by some of the talks later on as well. One of them is the bit manipulation extension, and the other one is the vector extensions. And these two are very helpful for doing crypto, for example. So that's number one. And then number two is this one, the privileged architecture document. And that's the document that's also been ratified in 2019, which defines the actually four modes, but only two of them are ratified today, plus the user level. So it defines machine mode, supervisor mode, and hypervisor mode. And people are working on the hypervisor mode right now. But the machine and supervisor ones are completely stable, and you can go ahead and implement them. And these are the ones that start giving you certain privileges compared to what you can do. The closer you get to the hardware, what you can do in terms of using the instructions, what you're allowed to do. All right, so these are the base specifications that were, so to speak, donated by Krister and Dave Patterson and a bunch of other co-authors to the foundation itself when it was created a few years ago. And this is what RISC-V works with and is trying to extend as we go. Okay, now a few words about security. How am I doing on time? A little bit more?
You have about 10 minutes left, maybe a little bit less.
Okay, cool. All right, so let's talk a little bit about security now. So there's a security committee, which is a horizontal committee, as I mentioned before. Remember the one that was blue in horizontal lines? This one was created around July 2018. There was already security activities going on before that, but in 2018, kind of as a follow-up to the Spectre and Meltdown aspects and attacks, the organization decided to actually create a standing committee for that, which is a committee that doesn't necessarily produce specifications, but that gets together to discuss any important security aspects that should be dealt with, and also which task groups to create that should actually come up with new specifications and extensions to deal with certain security issues. So the new chairs have been elected in July of 2021. So I've had, as Dan Page mentioned, I've had the pleasure of chairing this committee for about 3 years, and then I thought maybe it's time for somebody else to do that now. So there have been elections in July of this year, and the two new chairs are Manuel Offenberg from Seagate and Andy Dello from Huawei. I think they still use the same mailing list, so security@list.risc-v.org, that hasn't changed. As I said, all that gets posted on this list is public, so you can go ahead and see what they talk about and what they're discussing if you're not a member of it yet. And all the documents are currently still posted on this list.risc-v.org website, which is not necessarily public for the moment, but there's a plan to migrate everything to GitHub soon. So at some point, all of the discussions, all of the presentations we've had in this group and everything that's been done there will go onto GitHub. They continue to meet on Wednesdays typically, not necessarily every week, but when there's something interesting to discuss and to talk about. And they're also about to reinstate what we had called a speaker program, which was a program where we would invite somebody to present, security stories, something interesting, a new attack or something related to RISC-V and security. So that's going to be reinstated pretty soon. The original charter for this committee was the one that you see here. So it's really about promoting RISC-V as an ideal vehicle for security, for the security community, to liaise with other internal and external committees. So that means not only with other RISC-V committees that don't do security, but also with other organizations such as Global Platform or FIDO or others like that that have security as an interest. And so there's direct links between these organizations so that people can exchange, preliminary versions of specifications, make sure we don't, create something in one organization that's the opposite to the other one. That would not make any sense. So there's a good discussion going on there. And then the other ideas were to create, an information repository for new attacks, new trends, countermeasures, list whatever needs to be dealt with in terms of security for RISC-V, and kind of get things going. And so they're pretty much continuing this kind of charter and getting more specific on which kinds of security aspects they want to tackle. All right. So there's two task groups, as I mentioned, dedicated to security. So here you can see a little bit what the different task groups are working on. The first one is the crypto task group, and I should probably write that with a K because the extension is called crypto with a K. And it is led by Richard Newell from Microchip and Derek Atkins. You can see there's a link here, and you can get the slides afterwards, so you don't write it down. There's a link where you can find everything about the work in progress. They're mainly dealing with ISA extension proposal for scale RV32 and RV64. I'm giving you a little bit of a summary, but Ben Marshall is going to give an update on a big portion of this a little bit later today. So I'm not going to deep dive here, just telling you what's in it. ISA support to accelerate certain block ciphers and hash functions. There's also a raw entropy output register that's been discussed with BSI and FIPS, and both of them said it's okay to do it this way. There's also borrowing some instructions from the bitmanip specification, and so that's one area where this specification uses another specification to build on. And furthermore, there's a second version of these extensions being worked on, which are vector-based. And so there's more stuff coming up there. And then the second task group that we have dedicated to security, there's also other task groups that are interested in security, but these ones are dedicated to security. This one is the TEE task group, Trusted Execution Environment, and it's led by Nick Kosifidis from Forth, and Paul Koo from Andes. And I believe also Nick is going to give an update a little bit later today about everything that's going on in that group and all the security activities there. So just as a little bit of a teaser here, they're working on completing the EPMP and pushing it through ratification process. EPMP stands for Enhanced Physical Memory Protection. And then they're working on additions to that or other versions of that in the IOPMP space, the SPMP space, and so on, and a bunch of other topics, which I'm not going to go into right now, that Nick will be presenting later on. Okay, so lots of things going on. You can see very traditional topics and very cool solutions in the RISC-V world. And then one more thing that I think I can mention here is that there are also two special interest groups that kind of report directly into the security committee that are groups that don't necessarily write specifications, but that want to need to exist and need to be in charge of certain aspects of security for which we need to have people that are, accessible, that can answer questions and that you can send information to. So one, for example, is the security response team. This one is led by Don Bailey and Francis Allister. And what this is a team or a SIG that is in charge of setting up a process and dealing with security vulnerability disclosures. So we're not expecting to have too many of those, but you never know. So in case you find something that, is completely broken in one of the RISC-V specs and you think it's, worth saying something about it and having us perhaps change that and correct that, please send an email to this group saying, I got a bug, I got a security bug, and it better be fixed. So we do have this security vulnerability disclosure process in place. We've already received one such disclosure a few months ago, which has now been, I believe, published at DEF CON or the other one. Anyway, it was in August, so very recently. That was very interesting. And so there's discussions about how we will fix the spec to make sure that's not going to have too much of an impact. That group is working with a company or organization, I should say, called HackerOne. They have a platform solution to run these processes. And so this is where we will post the specifications for people to be able to make comments and to pick up reviews of these things and see if any, if you're a hacker, that's where you go to pick up a spec. And if you have a result, that's where you post the result back into the system. Okay, and then there's another SIG that's dedicated to blockchain. So this one is led by Patty Tu and Gary Chu. And what they were interested in was creating a group that was specifically dealing with how RISC-V specs could be optimized for blockchain applications. And by blockchain applications, we mean on the endpoint mostly. So they're making recommendations on additions and extensions to enhance performance and to trying to make sure that RISC-V is as competitive, so to speak, as other systems and specs out there that might be blockchain optimized. A few other things we've done before I conclude. There was an effort to launch a fence.t informal group, which is a group that would try to address microarchitectural covert channel effects. via secure cache management. It's a little bit hard because it's not on the priority list really of the cache management folks. So they deal with bigger issues, so to speak, to make it work first. And then we come along and say, look, we'd like to make this, secure as well. So we're kind of a little bit later on the list of when it's going to happen that this solution gets put in place. But okay, there's discussions going on. Somebody called Gernot Heiser from Data 61 had a solution proposed that he called the augmented ISA. But okay, we need to talk more to put it in place. And then more recently, someone called Suresh Sukumar joined the group and said, I would like to propose to study all sorts of other security topics that are not specifically being addressed or for which there is no specific specification yet. For example, control flow integrity, pointer safety, secure boot, confidential computing requirements, all of these things. So there's a bunch of topics that we all want to address. It takes time, but things have started. And I think Nick will talk a little bit more about some of these as well, because the TE group is picking some of these up already. But yeah, so we need a lot of people to help. There's so many topics to deal with. Hopefully this will have interest to you to the point that you'd like to join if you're not yet a member. And if you are already a member, please sign up to the security groups and help us get things done. So with that, I think I'm probably almost out of time. I am at my last slide. Yes, thank you very much. And don't forget the other talks after this one that will go into all the details of what we just talked about. Thank you.
That's great. Thanks a lot, Helena. So I guess we have a few minutes for questions if there are any. Like I said at the start, if you raise your hand, I can see that in the participants list, and maybe I can prompt you to speak it out if you want to, or if you prefer, paste a question in the chat and I'll try to sort of cherry pick some and read those out myself.
I think I'm seeing one in the chat.
Okay, that makes my life easier already.
Okay, let me go and answer that one. The question is, can you tell more on the status of confidential computing and secure boot? So secure boot is a notion that had been put on the list, on the to-do list by the TE task group early on. So they had started writing a specification about it. And then we realized that doing too many things at the same time wouldn't get us anywhere anytime soon. So they started by first doing ePMP, IOPMPs, and so on. And then after that's done, and Nick can tell you more about that, after that's done, that topic will get picked up again. So it's about writing a specification of how to do it correctly and making sure that all of the necessary hooks and elements are in the existing specs so that you can actually boot up securely with RISC-V. And confidential computing, I think, is a more recent notion. This is really about making encrypted islands, making sure that some of your VMs in your systems are encrypted correctly and are private to what you're trying to do. So this is a notion that is that sets out requirements, and we need to start looking within RISC-V what that means on a RISC-V for a RISC-V based system. So do we have all the necessary elements in the specs that would allow us to do that? And if not, we need to create new specs to do it. So it's the beginning only. So both topics are in the TE group. The secure boot, yes, the confidential computing has been mentioned, but I don't know how it's been split across groups right now. So maybe we will.
So hi, Helena, it's Andy Dello, the new chair of the Security HC. Just a quick update from me. The secure boot, we discussed setting up a working group, a working team, rather ahead of a working group to create a security model for RISC-V. There are a few volunteers who've put themselves forward to help do that work. We're very keen that more people join. So Mohammed, if you're interested in assisting in that effort, then yeah, we're going to create a security model which will include things like secure boot and attestation.
Great, thanks, Andy.
So I'll also, Nick here. So some issues we had with secure boot was that because on RISC-V we're trying to cover a large range of use cases. There are vendors that believe that, for example, we using asymmetric crypto for signature checking is not possible on some implementations. So there was a point that we couldn't even agree on what a signature is, and we were trying to find, the best approach that would fit most people. And in the end, secure boot ended up being mostly a software thing. And there are already standards out there. There are already people trying to do it. There are multiple open source projects and proprietary projects that have already done secure boot on RISC-V. So we focused on adding the hardware bits there that would assist in secure boot, and then discussing about the software aspect of it. But as Andrew said, now we are restarting this. But the thing is that the challenge is, I guess, to not reinvent the wheel, to not do yet another secure boot specification, and just provide the necessary mechanisms so that any secure boot implementation software-wise can work on RISC-V.
And yeah, there'll be your talk a bit later on still. Okay, that's the end of my talk.
Great, yeah. If there's nothing else, let's leave it there. Thanks, Helena, and move on to the next talk. So yeah, the next talk is by Ben Marshall, who is a researcher at the University of Bristol and an engineer at PQ Shields. And as Helena suggested, he's the editor of the RISC-V cryptography extension, which I guess very neatly summarizes what the talk is about, essentially. So Ben, over to you.
Unmute. Excellent. Good. You can all hear me, right?
Yes.
Wonderful. The joy of having Zoom on 2 monitors is that now I can see what I'm presenting, but I can't see any of you. So yeah, the fun continues. Anyway, thank you for the introduction. Yeah, so my talk is about the RISC-V cryptography extensions that Helena sort of introduced very happily in her talk. And like Dan said, while I don't have any official capacity within the RISC-V cryptography task group, I'm the sort of de facto editor of the standard. What that exactly means is that I do a lot of writing, but it does mean that also I can give you a pretty good overview of things. So yeah, I'm here representing the task group, and what I want to go through is basically what the cryptography task group has done so far, and sort of explain some of the rationale about why we've done what we've done and the order we've done it in. I'll give you a little overview of the scalar cryptography extension, which is now frozen as of maybe a week ago now, so it's very hot off the press, and something worth everyone knowing about, I think. And then sort of plans for what we want to do in the future and how you can all get started, because as Helena kind of mentioned, actually getting started with RISC-V, just navigating all of the different groups is very difficult, and I'm really glad